Hi everyone, I'm Bahar. I'm a Research and Development Associate at ANIMATAS Corporation. And today I'm going to talk about a bit of my background in research and industry, starting from the very start of where I started robotics to where I am now, and going into details about opportunities that you can do, the job search process to help you with your search next. So everyone has a different reason why they're in robotics. Mine was Rosie the robot from the Jetsons cartoon. It's a robot that's a companion robot that does housework, that interacts with people, personalizes interaction depending on the person that it's interacting with, like with children playing games, with the lady of the house shopping, and also has a personality on its own. So I said, well, this is perfect because it's who would want to do the housework if there's a robot in your house doing the housework? So fast forward to 2007 and 2012, I studied mechanical engineering and to learn how to build robots. And I actually made one myself together with two other students in the project, which was small mobile education robots that are made from plexiglass and are still used today in the 10 years later in Introduction to Robotics course at the Electrical and Electronics Engineering Department at Boston University, which I'm very proud of. And then I said, okay, perfect. I got the body of the robot. And so what's next? It's the mind, it's the brain of the robot. So I need to learn how to get the AI behind the robot. So I studied master's in computer engineering. And as I said, the housework is really important. I focused my master's thesis on loading a dishwasher with a robot arm. But everyone has a different way that they load their dishwasher. And from those who prefer to maximize the capacity, to those who prefer to minimize the time that it takes to load, and to those that actually prefer an orderliness within the dishwasher, that the mugs that are bigger or the dishes that are bigger are placed together so that they can place them back to their cupboards in that orderly fashion. So we created a user-centered design based robot for manipulation and task planning using several user studies to learn what people prefer when they're placing their dishwashers and their dishes, and also applying that both in simulation and in the real world to the robot, a custom robot you see there at the lab at the Boston University. That has a first sensor to detect the touch and object recognition to detect the mugs and so on. So it can create a user-centered planning in its motion when it's loading the dishes. And now that's the next, and also was part of the RoboCup Robot Football League, where I was designing motions for the robots playing football in the standard platform league in the Starburst team, such as goalie motions, kicks, and as well as behaviors for the technical challenges such as whistle detection and also finding the goal when there's no lines in the field and so on. And after that, I studied interaction, the human-robot interaction, because there's going to be a human in the loop in the house when the robot's going to interact with them, and the robot needs to personalize its interaction. So to start off, I studied user recognition that uses modalities, just face, age, gender, height, and the time of interaction of the person to detect if they're new or enrolled, and can also enroll them into their system by using incremental learning and sequential online learning. So that when the user changes their appearance, the robot can also recognize them in the future, which is also the first in the field, because the current methods, especially deep learning, requires thousands of images per person, or it only knows the person that it has in the system and cannot detect new users or cannot learn new users. And the code is available if you want to use it as well. going off from there, we need to personalize the interaction. So we studied rule-based dialogue architectures that can learn users' preferences in a coffee-based scenario. For a barista robot, the robot would learn what the customers would want from the robot and would ask them if they would like to have it again and learn their preferences over time. So it's normally should work, right? But with speech recognition and a fixed rule-based system, it doesn't work perfectly because people can go outside of the database, the structures that the robot knows, or the speech recognition may not work well. And it was in the case when we tried the robot in an international student campus in Paris, in France, in Steinwester. And then so I looked into data-driven architecture. So they're supposed to be more flexible. They're supposed to learn from data. But the thing is, they can learn generic interactions and perform as perfect as a rule-based architecture in theory. But it cannot learn users' personal information, such as their name and their preferences over time, cannot learn them incrementally, so it doesn't have lifelong learning capabilities for the state-of-the-art methods like memory networks and sequence-to-sequence models. And another project that we worked on, which was a 3.5-year project and a 2.5-year deployment of robots in a hospital in cardiac rehabilitation at the Fundación Cardioinfantil Hospital in Bogota, Colombia, was that the robot would help patients in their cardiac rehabilitation sessions, which are sessions that are offered to the patients after they have a heart problem. And it's an 18-week session, it's 36 sessions in total, so it's a long-term therapy, and the patients may lose their interest and motivation in the therapy, so that they might drop from the therapy, even though they didn't fully recover. So, and so the robot is supposed to improve their motivation in the therapy. And one way to do it is to personalize the interaction by using their name, recognizing them, and also giving them adherence feedback. So if there have been missing sessions, let them know, or if they had a comment on it, if they had a nice weekend, and so on. As well as do a progress feedback over time, so that they can track their session progress, how they progress over time in a session base, and they can give feedback whether they're improving, or if they're not improving, that they can get better over time to improve their motivation and belief in the goal of the therapy. So for instance, you will see that the feedback. So everything's been well, and we haven't had any problems, even though the session intensity is higher. So it's going to improve how they look at their therapy. And okay, I'd like to move from here. Okay, perfect. And next up, towards the end of my PhD, I was a Research and Development Lab Associate at Disney Research, where we designed a personality and would detect the emotions of the people and would have emotions of its own. So it's a character, it's an animated character that would adapt the conversation to multiple people based on its relationship with them and their emotion model, as well as its own emotion model. So you can personalize the interaction within a session and also within the long-term interaction with the person. And now I'm a Research and Development Associate at ANIMATAS, which is ANIMATAS serves Equipment, Industry and Commerce Incorporation, which is a company which does hospitality equipments for the hotels, restaurants, and patisseries, such as buffets and service cards, furniture for the conferences and banquets, and as well as chairs and tables, all the things you can see in the video. My father is actually the founder and the CEO of the company. He's also a mechanical engineer with a master's, and it's been yeah, it's been about 2 years that I've been working here. What am I working on? I'm working actually, and we're actually working with multiple international hotels around the world, which are quite well known, like Hilton, Marriott, Ramada, Accord, and so on. What I'm working on is divided in three actually. First is industrial robots. So how to customize the software that is offered by them in both a collaborative setting. So the robots doing, in the first view, the robots doing part of the setup and the humans doing the other part of the setup, as well as autonomous. So in the first one is autonomous, and the second one is controlled, teleoperated by the person. And here it's important to be able to customize this to all types of equipment that's created within the company with minimum efforts from the employees, and so they can improve the production line. And another part that I'm working on is virtual reality. So why we would think, well, so there's the metaverse going on. Exactly. So that's not the only reason, but the reason is so that we can offer companies, that the customers that wants to work with us a previous look into what their product will look like in the end, so that they can interact with it. They can see what are the things that they like or dislike about the product, so that what they can improve the product before we actually get into production, so that we can improve the time it takes to make a product, to decrease the time it takes to make a product, and improve the customer satisfaction, as well as decrease the time that it requires the employees to create the product itself. And finally, the third part is the smart buffets. So what is it? So say you have the food in the buffets, but they will all be different qualities. For instance, they will have different calories, different ingredients that may contain allergens, as well as different weights of the products, the dishes. So this systems actually can detect, can actually be entered by the customers themselves, by the non-experts, so that they can enter all this information pre-hand to the system, so that when the customers in the hotel or in the patisserie are looking at the buffets, they will know exactly what is in a system, as well as it can let the people behind the waiters know if there is any if the product is missing, if the dish is out, they need to be replaced, and so on. So if there's any problems with the buffets. And finally, it's a big announcement. I'm actually starting my postdoc in June at KTH as a Digital Features Fellow, which will be together with my supervisors, Gabriel Scanze and Sana Kopamaki. Gabriel is actually the co-founder of Forhat. So I'm actually keeping my foot in the door in the industry, but going back to robotics, the social robotics, for lifelong learning in open domain dialogue, basically continuing from where I left off for my PhD, to learn how people in the elderly care facilities interact over time with the robot using open domain dialogue. Now I'll give you an overview of my research. So you might wonder, so why do I prefer industry? Why is it not academia? So I'm going back to postdoc, but again, it's the foot in the door with industry. Well, everyone has a different reason for this. My personal one is that industry, I'm an engineer, and I'm also a product person as well as a researcher. I feel like there's a sweet spot in the industry where you can do research for a product. So it's difficult to find a company that actually does exactly what you want, so that you can actually still do research, still explore new opportunities while creating products that everyone can use in their daily life. For instance, for the Rosie the robot in the future, of course, as well as a rehabilitation robot the patients can use in real world, instead of keeping it to theory or experiments that may be put off the shelf after the PhD student leaves, for instance. So I want the end product. I prefer the end product, and that's why I prefer industry over academia. But also be able to explore within that product, develop that product further using research. And there are many companies that you can find online. These are some of the resources that you can look at the robotics companies for. But again, as I say, if you want to do research in the industry, there aren't many of the companies, because you can either choose startups or middle-sized companies, which are less in research but more product. Where in comparison to bigger companies, the mega corporations, which have their departments of research on their own. And when you do find a company that actually works in the area that you want, then the choice will come to where you would choose research scientist, a research engineer, applied scientist, researcher, software engineer. There are many terms that you can choose from. And the one that I prefer is research scientist, but because it's more research, like a 70% research, for instance, and then 30% development, 30% implementation, whereas engineer is like 70% implementation, 30% research. But this definition changes from company to company. So you need to be able to talk to them beforehand, or you need to actually look in the job description to see which of these, the research or the implementation, that the job description is actually talking more about. And again, it's for applied scientists, it's more about the product. Again, closer, it's in between, I would say, the research scientist and research engineer. And software engineer, of course, is all implementation, maybe just a bit of research. But for PhDs, I would suggest research positions or applied scientist positions or researcher position rather than a software engineer. But of course, if you all want to develop a product, a software engineer, of course, is really good as well. So now that you find the company and the job you want to apply to, you might want to you write your CV. So here's mine. It's by no means the ideal CV, but I developed it based on the resources I found online, and I'm going to go over it. But the first thing I want to say is, this is your maximum. You need to use 2 pages at most, and in general, it's 1 page. And the second page should be like the appendix in case it's needed. And the first page should give all the information. And as you can see, I didn't use any visuals. I'm a very visual person. I like putting nice graphs and everything, but in your CV, it shouldn't be. And one main reason for this is the applicant tracking system, the ATS, which actually scans over your text, your CV, and it needs to be doing that, the scanning on the text, so that it can match the keywords in the job description for especially the bigger companies if you're applying to them. And another thing is to use the white space as limited as possible. So you don't want white space in your paper, but also have areas where you can concentrate the attention to, because the 6-second rule in the industry is that the HR or the recruiter will just scan your CV in 6 seconds, just look over here and decide if you're worth looking into more or just that's reject. And so let's go at one by one really quickly. The first part is, of course, your name, your engineer, your position, if you're a computer engineer, mechanical engineer, and so on, your contact information, and then comes a summary. So what I preferred was who I am, my goal, how many years of experience that I have, and my focus of my research. So it kind of gives a feedback, gives a background without going into further detail into my CV. What are the areas that I worked on? Continue on is your skills. So this is really important if you're in industry, to have them not on the bottom, but like at the first center of the CV, so that they can match the job. And I keep on talking about match because when you write a CV, this is my generic CV, but I actually personalize it to the company that I'm applying to, for instance, because each job will have a different description. And as I said, the ATS as well as the HR is looking if you're matching those keywords in the job description. So if there's the keyword is communication in the job description, then you should be putting it there, of course, if you have it, in your skills. And if the technical skills are like ROS, for instance, that they're looking for in the minimum requirements, make sure to put the ROS there if you know. So, and don't overdo it. I actually had like 2 lines per each for these skills, but I decrease it based on the feedback from my friends who are actually in the, or also in the industry, and to a certain few. And well, there are others that you can use. So for instance, public speaking, curiosity, management, analysis, problem solving, forward thinking, responsibility, enthusiasm, design. These are all skills that actually come from your PhD. So you did public speaking, you gave presentations at conferences. Curiosity, you're exploring, you're doing new research, that's curiosity. Analysis, of course, you explore, you analyze your experiments. Management, did you time management, or did you collaborate with people and manage a project? Did you supervise a student, for instance? And problem solving, forward thinking, so of course, especially engineering skills, but also available in the social sciences for creating material for your PhD. You're responsible, of course. 3-4 years of PhD is very big, very much responsibility. And enthusiasm and design, as well as like creativity, determination. For instance, this is one of my strongest skills, because I mean, I keep on focused on my work, and that because I just want it to be finished. I just want to complete the project, and so on. So, and you can also find other resources here which talks about which are the skills, how they translate, what you did an experiment, how does that sound in the soft skills, in the, what does it translate to the soft skills. And then let's go into the professional experience. So I just took a part from the early stage researcher from my PhD. So for instance, Google's resume tip is to accomplish X is measured by Y by doing Z. So you increase customer satisfaction by 22% in 3 months by designing a new digital onboarding process. And mine was actually kind of in my CV, it's a bit different. I did Z, X, Y, but it's more or less the same formula, as long as you have X, Y, Z both in there, as long as you have what you did, what's the result, how did you do it. In your results, you're going to be able to match what they're expecting in a CV. Also, you might notice that I actually put references. So this is the second page. I put the publications in the second page. They don't need it. They just need to know that there's a publication. And if they want to know more about it, they can go and look into that publication, as well as the GitHub links. They're actually clickable, but be careful with this because ATS might not like it. So make sure that it actually works. Finally, the education. I would say if you already wrote your professional experience of what you did in your PhD, don't repeat it. Don't write your thesis in your education, because they're not going to want to know about it. The name of your thesis doesn't really matter. And yes, your supervisors matter, but it's also the space that you need to be very careful about. And if you're going to write your supervisor in your referees, there is no need to write your supervisors. This is not a publication. For instance, this is your CV trying to address it to the industry. And of course, if there is a common connection, you can always talk about it in your cover letter. And here are some actually the excellent tips on writing a resume and for courses on that. You can watch the video later to see all these resources again. And there's also much more online, but these are the ones that I found the best to be, in my opinion. So again, as I said, the second page, I have my the workshops that I organize, the talks that I give, it selects not all in detail. Your best work has to be there. Again, best honors, best awards, publications, best of them, not all of them, because if you're going to write all your publications, it's probably going to take much more than 2 pages. And given that I talked about my work in 10 minutes, I need to put that all in 1 page. It's already very limiting, and you need to be able to do it in best as you can in short bulletlets, because that's what they're expecting in the industry. And finally, your cover letter. Do not repeat your cover letter, your CV in the cover letter. Don't paraphrase what you wrote in your CV, but actually write how that experience, how what you wrote in your CV translates to the job description, to their company. So you designed an experiment. You're going to say, I can design new user studies for this product in your company, so we can know actually how that will be more liked in the market, for instance. Or like if they would give you tips actually in the job description, or you also need to go and you actually need to go to the company website, look in their papers if they have any, look in all the blogs you can find to see what you like about the company and how you can fit in the company, and make it all about them in your cover letter and not about you, because they're not doing you a favor by hiring you. They need to do themselves a favor by hiring you, and you need to make them know that this is indeed the case, that you're actually the best candidate for them, so you can actually improve their company, not yourself, basically. And when you got everything ready, your CV and cover letter, you need to actually reach out to a person within the company. If you already know them from conferences or I don't know, seminars and meetings and so on, it's perfect. It's a perfect opportunity to reach out to them and say, do you want to have an informal chat? Not an interview with a person. Don't push them, but just send an email. Don't be afraid. That's the trait, because the worst they can say is no. You won't humiliate yourself. They will probably getting thousands of connection requests from LinkedIn or emails from them. And if they say yes, I have like 15 minutes to talk to you about you, make it that's perfect. Don't make it all about you. Just give it like 2-3 minute brief overview of why you will be a best fit in the company. But again, not a sales pitch. It's something very informal, but also learn more about the company, because what you see online might not be what you get actually at the company, because the projects might be different, the inner workings of the company might be different. You might not like it, or you might love it. So it's really important to actually reach a person. And also you will see online that the references, actually, like if someone refers you in the company, your CV is more likely to get in than if you just submit it online. So it's really important, but don't just get a connection just for the sake of reference, but actually reach out and actually get to know more about the company, so you can decide what you want to do for the at least 2-3 years of your life, and if this is the right choice for you. And one excellent, as I said, is opportunity for this is conferences and workshops. Whether you're a participant in them or organizer, these are excellent opportunities to meet from people from both academia and industry. So all my tips, of course, apply to academia as well, but I'm just focusing on industry. And this is conferences, especially like something like HRI, is a perfect way to actually meet these people, these new people who are working in similar areas and that then you want to work with as well. Now that you sorry, now that you submitted your CV and cover letter, you reach out to the person, you submit your cover letter, it's going to take some time. So better start it early, because applications, especially if it's big corporations, can take 2-3 months for a return. Even if you know someone, even if there's a reference, they might not have a set job, even though they have advertised it. They might still be going on the details behind the curtains. So make sure you start early. Let's say you want to start a job in September. Better start your job application now, because it's going to take 2-3 months and another month or 2 of interviews, and then visas if you need to, and so on. So it will take some time, and you need to be able to know about that. Don't think they don't like you. They don't think this is all against you. No, this is normal. This is the norm, especially if it's big corporations. They receive thousands of applications every day, and it's not going to be easy to get noticed. And that's why this is all about getting noticed. And great, you got an interview. Perfect. In the meantime, by the way, when you're waiting, you need to study for the interview, because it's not something you go in without knowing. It's not. Think of it as an exam. You need to know. You need to study before actually getting into it. And hold on. And so there's 2 types of interviews. One is the behavioral type, where you're going to get classic questions like, where do you see yourself in 5 years from now? So tell me your greatest strength, your weakest weakness, and so on. But don't answer them something you find on the internet. Actually make it something about you. Tell them a story. Tell them there's a STAR method: the situation, task, action, and results. So you need to put them in a situation, the story, and then tell what you did. Tell tell what was the problem, tell how you did it, and tell the results. Again, as in your CV, you need to do accomplished this by which improved this, and then by doing that. You need to actually be able to know these questions before. These are very classic questions that you can find online and get yourself ready to. And the second is, if you're applying for software engineering, research scientists, or roboticist positions, you're going to actually need to go into a coding interview, which is classic. It doesn't have to be, but most companies have this. And some are the excellent resources. The Cracking the Coding interviews is known as the book for this, as well as the algorithm design and system design. And there is the Google's or like technical interview, Learn to Code with Me, and so on. These are excellent resources. But you also need to do coding before you actually get into that interview, because you can have like whiteboard questions as well as coding online at the same time as they can see it. So it's really important to practice your coding skills for known questions that most companies ask, and you can do it with LeetCode or other types of websites for free as well. And finally, you did everything right, but it didn't work out. Don't worry, you're not the only one. It happens. You're going to have to go through many doors before you actually get the position you want. Yes, you're excellent researchers as PhDs. Yes, you're roboticists, or you did a lot of work, you did a lot of papers and so on, 3 years of PhD, maybe 4 years, and you're thinking, I did everything right, why I'm not getting the job? Maybe it's not the one for you. Maybe you need to try again, but you will eventually find it. So don't give up hope. Keep on trying until you actually set your foot in the door and get where you actually want to be. But don't apply to everywhere, because this whole job application process is actually consuming a person. And it's good practice to do interviews, these practice interviews, so you can apply. But don't do it to companies that you're not even remotely interested in, because you're wasting their time and your time as well. So try to do it to companies you're at least having some common interest and might think, oh, I can actually work here, so that you can get to know about it, more about the company and more about what you want as well. throughout this whole process. And here are some of the references that I just, the main references that I put in for my work. And always feel free to reach out to me with my LinkedIn or email if you have any questions. And I wish you the best in your search for a job, and I hope, and I know you will get the best as well. Thank you very much.
That was fantastic. Thank you very much.